Hello, you welcome to this lesson. In this video, we are going to learn about conditional probability. So let's look at what conditional probability is. So the probability of one event happening may depend upon another event having taken place. Okay, so that's to say that the probability of an event occurring may depend on the fact that one event has already occurred. Okay, so the probability of one event will be dependent on on another. That's what conditional probability is about. So here I have that if any two events, say event A and B, are such that the occurrence of event B depends on that of what event A, then the conditional probability that B will occur, given that A has already occurred, is given as the probability of B given A equals what probability of A and B over what probability of A, which is the same as probability of what A intersection B over what probability of what A. So if you have two uh, dependent events, and then say event A and B, and then the occurrence of event B depends on what event A, then we can express their conditional probability as what we have here, which is what probability of B given A has already occurred equals what probability of what A intersection B over probability of what A. And then you know that wherever you see end here, that means you are talking about intersection. Okay, so take note of that. Okay, so over here we have if A and B are independent events, then the probability of B given A has occurred will just be probability of what B, right? Because B is not dependent on what A. So in that case, you are just going to have probability of B given A to be equal to probability of B because B doesn't depend on what A. So in that case, you're going to have probability of A intersection B to be equal to what probability of A times what probability of B. And then also if A and B are mutually exclusive, then the probability of B giving A would be what? Zero. This is because if A and B are mutually exclusive, then that means that they are not going to have any common let me see, they are not going to have any common value. Okay, so their intersection is going to be zero. Okay, they are not going to have any common outcome, so their intersection is going to be zero. So in that case, you are going to have zero divided by probability of A here, and then you know that's going to give us zero in all. So let's take note of that. Okay, so for us to understand this, I have an example here. Let's take the example so that we will understand this better. Okay, so the question says the table below contains 400 parts that has been classified by surface flaws and then as functionally defective. Find the probability of D given F has already occurred, and then the probability of D given F prime has already occurred, and then probability of F given D has occurred, and then probability of D prime given F has occurred, and probability of D prime given F prime has already occurred. Okay, so now let's look at this table that I have here and then explain things to ourselves. Okay, so from this table here, we have surface flaws and then defective parts. Okay, so for the defective parts, we have parts that are defective and then parts that are what not defective, right? And then you have parts that have surface flaws and then those that do not have surface flaws, right? And then you have the totals also. So D will represent parts that are defective, right? So in that case, D prime will represent parts that are not defective. So I will put D prime here. Okay, parts that are defective, that's D. Those that are not defective, that will be what D prime. Okay, and then parts that have surface flaws will be F. So those that do not have surface flaws will be what F prime. Okay, so let's take note of this. All right, so let's look at the first part, which says that we should find the probability of D, okay, given what F has already occurred. So the probability of choosing a defective part, okay, given that you have already chosen a part with what a surface flaw. So that's going to give us the probability of what D intersection F, right, over the probability of what F, right? This is what you are going to have. Okay, so we must find the probability of what D intersection F, right? So let's look at that. So the probability of D intersection F, okay, That's a part that is defective and also has a surface flaw. Which part would that be? That's going to be this 10 here, right? So 10 parts are defective and then they have surface flaw. So their probability, okay, is going to be the 10 over the total number of parts. That'll be 10 over what? 400. Now let's find the probability of what choosing a part with what? A surface flaw. Okay. So all these parts have surface flaws and then their total will be what? 40. So the probability of choosing a part with a surface flaw is going to be the 40 over the total 400 parts that are available. So therefore you're going to have the probability of D given F has already occurred to be 10 over 400, okay, divided by 40 over 400. Okay, this will be equal to 10 over 400 times times 400 over 40. Okay, this will cancel out this and then you're going to get what? 10 over 40, okay, which will be 1 over 4. So that will be the conditional probability for D given what F has already occurred. So let's look at the second question also. Okay, so II. Okay, so for II also we have to find the probability of D given that what F prime has already occurred. So the probability of choosing a defective part given that a part with no surface flaw has already been what chosen. So that's going to be the probability of D intersection F prime divided by what? The probability of what? F prime. So now let's find the probability of D intersection what? F prime. Okay. So let's find parts that have no surface flaws but are what? Defective. That will be this 18 here. So their probability, okay, that's the probability of D intersection F prime, okay, is going to be the 18 over the total number of parts. That will be 18 over 400, right? And then the probability of um, choosing a part with no surface flaw, okay, that's going to be all these parts here have no surface flaw, so you add them and then that gives us the 360. So that's going to be 360 over the 400, right? Okay, so now let's go ahead. Okay, so we're going to have this to be equal to 18 over 400, okay, divided by 360 over 400. Okay, this is going to give us 18 over 400 times 400 over 360, right? So this is going to cancel out this. So at the end, you're going to get 18 over 360 for this also. All right, so now let's move on to the next question. Okay, so the third question says that we should find I. It says that we should find the probability of choosing a part with a surface flaw, given that a part that is defective has already not been chosen. So let's look at that. So that's going to give us the probability of F intersection D over the probability of what D. So now let's find the probability of F intersection D. Okay, so we are looking at parts that have surface flaws and are also defective. That's going to give us the 10, okay, over the 400. Okay, let's find the probability of choosing a defective part, right? Probability of choosing a defective part. Okay, that's going to give us these are the total number of parts that are defective. So we are going to have this to be equal to 28 over 400. Okay, so in this case, you're going to have this to be equal to 10 over 400 divided by 28 over 400. Okay, this is going to give us 10 over 400 times 400 over 28. Okay, so this will cancel out this and then you're going to have this to be what? 10 over 28. Okay, so now let's look at the last two questions. Okay, so the last two questions says that that's IV. Okay, it says that we should find the probability of D prime, given that what F has already occurred. That's going to give us the probability of D prime intersection F over the probability of what F, right? So let's go ahead and look at what you are going to get. Okay, so first of all, let's find the probability of D prime intersection what F, right? So let's look at that. So the probability of choosing a part that is not defective, okay, but has a surface flaw, that'll give us this 30 that I have here. So that's going to be 30 over the 400, right? And let's find the probability of choosing F, which is a part with a surface flaw. That's going to give us 40 over the 400. Okay, so in this case, you're going to have 30 over 400, okay, divided by 40 over 400. Okay, this will be equal to 30 over 400 times 400 over 40. So then you're going to have 3 over 4. Okay, so I'll leave the last question for you to try your hands on.